Okay, so we're looking at day 3 of circles here, and we have a little entry task that says match each term with its definition. So we have radius is the first one, and the radius is the distance from, and if I draw a circle here, hopefully I can draw a decent one. We have the center of the circle. If I go out from the center in any direction, so from the center to any edge, that's the radius. So it's the distance from the center to the edge of the circle. So this would be my radius. Now my diameter doesn't just go halfway across, it connects and goes all the way across. And once again, my diameter and my radius can be from any side as long as it goes through the middle to another side and it's a straight line. So my diameter is going to be a distance across the circle and through the center, so it goes all the way across. Then we have the circumference. The circumference is the outside of the circle. It's the perimeter, so it's the distance around the circle. And so the distance around the circle is right there. Our last one then is pi. And pi is that beautiful ratio where I am taking the circumference and dividing it by the diameter, and that is what gives us our pi. So down here we're going to be working, when we work with pi, we're going to be squaring some things. We want to make sure we know how to square. So when I see that little 2 up there, that means I'm going to take that number and multiply it times itself twice. And so I'm going to do 2 times 2, which is going to give me 4. And now I'm still going to multiply that times 5 rather, and I get 20. Over here I have the same thing, so this is going to be 4 times 4, which gives me 16. I'm still going to multiply that times 7 and add 3. And of course, I just closed my calculator, so 7 times 16 is 112. Plus 3 gives me 115. On our last one, I have something squared equals 25. And so remember, everything in math has a way to undo it. So the way to undo a square is to do the square root. So I'm going to do the square root. And that means what that number that could be squared equal 25. So that is going to be 5. Now typically when we do this, we say that our square root could be a positive 5 or negative 5, but because we're going to be working with something that's a distance, we are only going to be working with the positive values. I'm sorry, that just looks awful. Let's try that again. Since it's a distance, we're only going to be using the positive 5, but we could have 5 times 5 is 25, and negative 5 times negative 5 is also 25. So that's where we would get the positive or the negatives there. There is a YouTube video that you're going to want to watch, and that will help you figure out where this circle area formula comes from. It is really cool. I know, I love all things math, but this is actually really neat to watch. So once we come up with this formula that defines the area of the circle, I'm going to do pi times the radius squared. And a little bit about that. If I take a circle, because a circle is nice and all the radiuses are the same, that means from here to here is also the same as to here, and to here, and to here. And so if I take my radius and I square it, that would give me the area of this square right here. Radius times radius, so that's where the radius squared comes from. Now you're like, oh look, there's like 4 of those squares. Well, if I were to multiply it times 4, then I would have all those extra pieces. I don't want those extra pieces because, as you can tell, because of the circle doesn't fill those in. I don't want those. So that's where my beautiful ratio of pi comes in. So instead of multiplying by 4, I multiply by something pretty darn close to 4, 3.14, and that is how I find my area of my circle. So we can use this to figure out something like an earthquake, how much area would be affected by the earthquake, because it goes out from that epicenter. The shock waves emanate out from that epicenter. So the distance of intense shaking from the epicenter of a particular earthquake to the outer edge was about 134 miles. So that is from the epicenter to the outer edge. So we're looking at a radius here of 134 miles. And they can also go back the other way and look at how far out the shaking was felt to figure out how strong or powerful the earthquake was. So it's telling us we're going to use this for pi, and it wants us to figure out the nearest square mileage that felt that intense shaking. So my area is going to be pi times the radius squared. So my area, they just told me for pi, I'm going to use 3.14. And then it told me my radius was 134 because it said from the epicenter, which is the middle, to the outer edge. Grab my handy calculator here. And I'm squaring 134, and I get 17,956. And also, 134 miles is close to the distance from Cincinnati to Columbus, so that would be how far away the intense earthquake would have been felt. And that will give us an area. This earthquake affected 56,381.84 miles squared, or square miles, however you want to think about that. So that means I should be able to draw 56,381 little tiny squares in there showing how much of that area was affected. For this next one, they're talking about a hurricane, which is something else that has a circular pattern, and we can then try to figure out how much area has been affected by that, what it's going to hit and what it's going to cover. Now on this one, it says the diameter of the eye of the hurricane was 30 miles. So the diameter of the eye of the hurricane, so remember we're going to go all the way across, that was 30 miles. To the nearest square mile, what was the area of just the eye of the hurricane? Well, you know that our formula uses pi times the radius squared. So I'm going to have to take that diameter of 30, and I have to figure out that the radius is half of that. So the radius is 15. And it's telling me once again to use 3.14 for pi. So 3.14 times 15 squared. Now I often have people go, oh, well, 15 squared is just 30. No, this is not times 2. This is 15 times 15. And that is 225. Now I still need to multiply that times pi. So I get an area of just that little tiny, what it looks like on that picture, this little tiny black dot is 706.5 square miles. That is a lot of square miles that is affected in just that little tiny dot, so you can imagine how big this actual hurricane is. We're going to do one more on the back before the rest on the back is partner practice. And we have Mark has a circular garden with a diameter of 20 feet. So I'm going to go ahead. Here's about my center. My diameter, remember, goes all the way through, and that is 20 feet. And he has planted equal parts of carrots, tomatoes, beets, and green beans. So I have carrots, I have tomatoes, I have beets, and I have green beans. So I have 4 vegetables total. And they want to split that and do the sections. So if this is my square or my circle with the diameter, they're essentially taking this garden and they're going to split it into 4 pieces. And they want to know how big is just one of those squares. How much area is taken up by each section. So the area is pi times the radius squared. So again, I have to look at, I have the diameter of 20, which means that the radius is going to be half of that, which is 10 feet. So area equals, and they didn't tell me what to use for pi. If they don't tell you, you can either use 3.14 or you could leave it in terms of pi. I'm going to show both. They're both going to be multiplied times 10 squared. So 3.14 times 100, which is 314, and that would be feet squared. And this one would just be 100 pi. Now that is for the entire circle, and I just want to know for one of the 4 sections. So I'm going to take this and I'm going to divide it by 4. 100 divided by 4 equals 25 pi. This would be my exact answer. 25 pi feet squared is how big one section is. Now, if I want to have an actual number, which typically we want an actual number, you'll see that exactness used when you're in the middle of equations and stuff in higher levels of math. If I divide 314 by 4, I get 78.5. So the area of one small section is 78.5 feet squared. And you think 25 times 3 is about 75, and then that 1.4. So you could put your answer in terms of this or in terms of this. The rest of that is partner practice. Good luck, and let me